So you have given this using okay, so this is a structure, benzene is there, and then CO08. So this is an ester basically. As the only organic material, so you have only this organic material and these regions are given. So you need to synthesize the following compound, not more than 7 steps. So basically you need to get this compound. So benzene, yes, there's a carbon here and a double bond here, and hydrogen is here. This is another one, and this is a CH2 benzene. So you see here at first point there is only one benzene here, there are 3 benzene. So basically it shows there should be 2 benzene that is attacking this one benzene compound. Sorry again. So as I discuss always, so think about one step before what it could be, what it can be happening here. So this could be something maybe like this. There could be OH here and then hydrated to get this product, so or heated just to get this product. So this could be like OH here and CH2 with this benzene part. I will just write a circle, and there is this benzene part here, and there is the CH2 benzene part here. So what could be the previous step now? Because I see here 2 CH2 benzyl groups. So it could be something, this benzene. Okay, if you remember about your organic chemistry really well, this could be something like this CO, either a Cl structure or an ester structure. Okay, CO or ester structure that is attacked by a benzylic Grignard reagent, because this Grignard reagent, when attacks twice, this forms. Then you dehydrate, this can be formed. That's the basic idea when you come from the back. Then you need to come from the front here, as I do every time. So what you can do to obtain this molecule and this molecule. One thing that you can form, this molecule is automatically there. So this is an ester. So when you have this one, when you attack twice to this one, automatically this will form, and then you dehydrate, this would form. But you need to take this one. So for that, what you can do here is, so you have given lithium aluminium hydride. So you can hydrolyze this compound, right? So ester hydrolysis. So you do the ester hydrolysis. So you will get, basically when you add lithium aluminium hydride, S plus H2O, so you will end up this with CH2OH. Okay. Otherwise, you can hydrolyze using H plus H2O. So H plus H2O will give this carboxylic acid, COOH, and then you need to use lithium aluminium hydride to get CH2OH. Okay, but the easiest thing is just to use lithium aluminium hydride. Okay, so when you use lithium aluminium hydride, automatically it will be easy for you to go back from ester to automatically to the primary alcohol, because when you do that, it will be very easy for you to directly do this thing in one step. Okay, so when you add lithium aluminium hydride first, and second you add H plus H2O, so you will have the something like a benzyl alcohol, so like with primary group CH2. Then you have given PCl3, so you can add PCl3 to form the CH2Cl group. Then you have magnesium diether, so you will get this one, and then you add this to this ester, and as a second step, so you need to add this one excess, otherwise there will be no two attacks, and then you add H plus H2O. Okay, so you will have this one, so plus this one. In the second step, you need to add H plus H2O. Okay, so that is the easiest way. You add the lithium aluminium hydride to this one, hydrolyze to get the primary alcohol here, add PCl3. So this should be first step, PCl3 adding second step. So forming the Grignard is the third step, and you finally add this one to this ester. It will be fourth step, and then hydrolyze. So it will be fifth one when you hydrolyze it. Okay, or either you can add 1,2 here just to get the 4 steps. Otherwise, what you can do is you can go for hydrolysis with H plus H2O. Okay, so when you hydrolyze this with H plus H2O, you are going to end up with getting the benzoic acid, COOH. This alcohol is automatically formed here as well. So there will be CH3OH methanol formation. So this one you can add now lithium aluminium hydride to get reduced to the primary alcohol same way, CH2OH. Then in the same way you add PCl3, Grignard, and attack this ester, or either you can make this COOH as a acyl chloride COCl by using PCl3 as well. Okay, what I am telling is this reaction. So when you hydrolyze, you have this carboxylic, right? This one. So you add PCl3, okay, to get the acyl chloride COCl. So then you can add this Grignard to this one. It will attack twice. Okay, this is a very simple, easy question. Not hard and simple. So see the approach. As I told you many times, you can come back from the back and you can come even from the front. So I came as much as possible. So I thought, okay, this could be a like a dehydration step. So I added OH. And I can see now, okay, if I add OH, so there are similar compounds. So from here, I can think, okay, this could be something like this and attacked by something like same two compounds. So this could be a ester or acyl chloride that can be attacked. So that is why I now come from the beginning to make this compound, because this is already there. So you can use a portion of it. But this one needs to be prepared from here. So the easiest thing is to make this is to hydrolyze this, get the primary alcohol, add PCl3, get the Grignard, and you will have this automatically. So this is the important that of thinking a particular reaction from the front as well as from the back. Okay. Right. Show how you would carry each of the following conversions. Not more than 3 steps. So you should be 3. Okay. The first one is so you have aniline. Okay, you have aniline and you need to make this bromo parachlorine compounds. Okay. So the easiest thing to do is what you can do here. The simplest thing that you can draw here is make this. If you think like, okay, I have NH2. So what I can do is add a chlorine here in the para position, or either bromine in the para position, and change this NH2 to either bromine or chlorine. This would not happen. Why it is not happening? Remember, NH2 aniline is a highly activator, right? High activator. Okay. Aniline is a high orthopara activator. So if you think like adding a Cl like Cl2Fe or something like that here for the chlorine added, so it will give tri-substituted product NH2 with 3 chlorine. So it is problematic. You cannot do that. So the easiest way to do here is making this one first a diazonium salt, right? So how you do this one? So if you remember, NaNO2HCl at 0 to 5 degrees Celsius, you make this. And then you can obtain either chlorine or bromine by adding CuCl HCl will give Cl, CuBr HBr will give this one. Then when you have this one, you can get this one. Okay, Cl Br. Okay, so how many steps? 1, 2, 3. Okay, not more than 3. So just 3. Very easy. So don't forget, you cannot just add this NH2 directly to get the chlorine product because it will give tri-substitute. Okay, another one. So CH2, CH3, CH3. So you have to obtain this one. So easy thing. You see these two are in meta positions. The first thing that you can do here is to add a meta director here and direct the CH3 group there. So the easy thing is to do this CO CH3. Okay, because that would be the easy one as a first step. Then you can, so how do you add this? COCH3Cl and hydrous AlCl3. And then you add CH3 again. So CH3Cl and hydrous AlCl3. So you will have in the second step CH3. And here there will be COCH3. Then you need to come from here to here. So what is the easiest way to remove COCH3? That is the Clemmensen reduction. So Hg zinc concate Cl would give you COCH3 to CH2CH3. COO is replaced by 2 hydrogen. Okay, Hg zinc amalgamate, Hg zinc conc HCl. So the reduction will happen to give this. How many steps? 1, 2, 3. Again 3 steps. No problem. No problem. Okay, so these are very simple things. Okay, the following reaction gives 2 products, right? The structures of the product and the mechanism. So this is, I think I have discussed this many times. Even in this previous structured essay questions also, we saw something like that. Okay, so here we have CH3 and CH2. I will write down this hydrogen separately because in order to explain that. And we are like this. So what is this 2 product? So remember, C2H5OH is a nucleophile, and at the same time it is a base. So when it attacks here, remember, it can act as a nucleophile and attack the CH2 group and remove this Br to form the substituted product. Okay, SN, nucleophilic substitution. So there will be hydrogen here, and there will be CH2 here and OC2H5. So this is ether. Or else what it can do here is this can attack the adjacent hydrogen, and this bond will break here, and this bromine also going to remove like this, and now it would form the dehydrated HBr minus HBr product, which is our alkene. Okay, CH double bond CH2. So this is what they are asking. Okay, So two products can be formed. Why? The reason is this ethoxy nucleophile or base can attack the carbon that is attached to bromine or the adjacent hydrogen to remove HBr to give an alkene or to give a substituted product, the ether here. Okay, so these two structures you can draw here and write the mechanism. So this is the mechanism. Okay, O- attacks the carbon and Br removes, and this product is formed. The other one, the formation of alkene, this O- attacks this adjacent hydrogen, this bond breaks towards this to forming the double bond, and this Br removes. So these are the two structures and the mechanism. Okay.